जी तो स्टार्ट करते हैं। हम पढ़ रहे हैं सूडो रैंडम नंबर जनरेटर्स। सूडो रैंडम नंबर जनरेटर्स means a generator who it's a piece of code or it's a computer program that generates random numbers. Otherwise, and of course, these numbers are not real. They are pseudo. They are not real. इसका मतलब क्या हुआ कि actual numbers are actual real numbers or actual random numbers MnS means numbers are generated by hardware. For example, if we have a reverse bias diode and we measure the voltage drop across it, VD, a reverse bias diode, and we measure voltage drop across it with certain degrees, with certain decimal positions, in a working computer or in a working circuit. That would be an example of a real number. That would be an example of an actual random number. But random numbers, they are very slow. There are various problems with these kind of actual random numbers, because collecting them can be difficult. Collecting those numbers can be time consuming. So most of the times, for the purpose of simulations, we rely on pseudo random numbers. Why do we require random numbers? Because we use them we need them. In fact, we need them for simulations. हमने बहुत सारे simulations पढ़ी हैं. In almost every simulation we have drawn random numbers. We need them for simulations. हमने पढ़ा हुआ है. In Python we studied. In Python we can import. क्या पढ़ा हुआ है हमने? Import the random library, and then we can use that to generate this library can be. और अभी हम देखेंगे in the third part of this lecture that this library, और हमने इसको बहुत ज़्यादा यूज़ किया हुआ है. This library, we have used this library. We have used this library a lot in this course. इस लाइब्रेरी को बहुत ज़्यादा यूज़ किया हुआ है इस कोर्स में. Import random library we have used. This random library is based on pseudo random numbers. They are not generated by hardware. Actually, they are generated by computer programs. So pseudo random number generators, pseudo random numbers, PRNs, are generated by, not by hardware, they are generated by computer programs. They are generated by computer programs. PRN pseudo random numbers are generated by computer programs. So we have good computer programs to generate numbers, pseudo random numbers. Why do we require them? We need for simulations. We have studied Monte Carlo simulations, and we have studied queuing, as well as we have studied sample probability distribution. अगर आपको पता है कि to sample a probability distribution, we require random numbers, and for that we have used this random library. We have used that library a lot. So what are the characteristics of pseudo-random? Actually, there are 4 characteristics. There are four major, in fact, there are 3 characteristics for PRNs, pseudo-random numbers. PRNs are pseudo-random numbers. PRNGs are pseudo-random number generators. Generators, when we say generator, this is not an electricity generator. Generator means it's not an electricity generator. It's not a 220 kilovolt generator. This generator is a computer program. Okay? This generator is a computer program. So we require these computer programs to simulate various real-world scenarios. And there are three main characteristics of PRNs, characteristics of pseudo-random numbers, of PRN pseudo-random numbers. कौन से हैं जी? Three characteristics. Number one is, it's a good thing about random numbers, they are efficient. Can be efficient, and they are actually efficient. They are actually efficient compared to their hardware counterparts. Their hardware counterparts aren't that efficient. They are efficient. Efficient means you can collect them easily. You can collect, for example, you can collect thousands of random numbers in a second. And why do we need that? Why do we need to collect thousands of random numbers in a second? मतलब क्या advantage है? What's the use? It's the basic use. The most obvious use is or in computer games. Or in computer games where we need thousands of random numbers in a second. And of course that we cannot do using their hardware counterparts. So that requirement is fulfilled only by the pseudo-random numbers, because they are generated with the help of a computer program. And of course, computer program can run very fast and can generate random numbers for you very quickly. ये इसका advantage है. मतलब इसकी characteristic है कि you can generate random numbers very efficiently, very quickly. Efficient मतलब quick. Number two characteristic is their determination. Determination means you can determine what will be your next random number. If you can determine, then how is it random? You can determine the next random number. You can determine the next random number. फिर क्या रैंडम तो ना हुए? They are not random. इसका मतलब क्या हुआ? कि they are not random. अगर आप डिटरमिन कर सकते हैं कि आपका नेक्स्ट रैंडम नंबर क्या है, they aren't random. Well, random number चूँकि ये pseudo हैं, तो therefore pseudo means they are actually they are not random. They look to be random. मतलब ये कि all PRNGs in this world, they start with, since they are a computer program, they all are computer programs, they start with a starting point, of course starting point, and we assign their starting point a name that is seed. So all PRNGs, they start with a seed. This means seed means the starting point. Seed is the starting point. So if we somehow know the seed, of course we can determine what's the sequence of random numbers they are going to generate the next. Seed is the starting point. Seed is the starting point. So if we know the seed, the starting point, we can know the next sequence, of course the whole next sequence. If we know the seed, we can know the whole next sequence of numbers that will be generated. So determination is another characteristic. So seed should be secret. If seed isn't secret, A seed isn't secret. Anyone who knows your algorithm, your computer program, can know the next sequence of your random numbers. So seeds are important, and of course there are other parameters except seed. But seed is the most important thing. That is the starting point, and if we know the seed, we can know the next sequence, and of course then the process isn't random. The third thing is they are periodic. The third characteristic is they are periodic. Periodic का मतलब क्या होता है? साइन वेव periodic होती है ना? Sine wave is periodic. क्यों कहते हैं periodic? Because after this period, it repeats itself. It repeats itself. Sinusoidal wave को कहते हैं हम कहते हैं ये periodic है. Periodic. बिल्कुल similarly, these numbers are periodic. The numbers that we generate using a pseudo random number generator, they also have a period. We have number 1, 2, some random numbers, and then we start repeating that sequence again. So that period actually depends on many things: your starting point, your seed, and other parameters. So seed is very important. So depending on your seed selection, your numbers can be they do have a period. After that they repeat themselves. तो ये कोड मतलब हार्डवेयर में ज़रूरी नहीं है. If you have hardware generators, this is not exactly true. They don't have a period T. But pseudo-random number generators generated by a computer program, they are periodic. But they're efficient. It's an advantage. You can determine it's a disadvantage. They are periodic. They can be periodic. We can tolerate that, but the period should be very large so that we don't have repeated numbers all the times. ठीक हो गया जी. तो next is हम क्या पढ़ने वाले हैं? We're gonna study 2 basic random number generators. There are many PRNGs in this world. बहुत सारे PNGs है. बहुत सारे PRNGs का मतलब क्या है? इसका मतलब है कि there are many computer programs that generate PRNs. तो PRNGs का मतलब क्या है? PRNGs कितने हैं? बहुत सारे हैं. हम सारे नहीं पढ़ सकते. तो PRNGs are many. PRNGs. There are many PRNGs. But we'll study only 2, the 2 basic. The first of the 2 is middle square method that was introduced by my favorite, the great man, middle square method. My favorite scientist, क्या नाम है? मैंने आपको बताया हुआ है. John von Neumann. ठीक है. von Neumann ने बनाया था मिडल स्क्वायर मेथड, जिसने मॉडर्न डे कंप्यूटर बनाया. और एक और मेथड हम पढ़ेंगे, उसका नाम है जो कि बहुत यूज़ होता है, सबसे ज़्यादा यूज़ होता है, लीनियर कॉन्ग्रुएंशियल जनरेटर. लीनियर generator. LCG. Linear congruential generator. Lehmer. ठीक हो गया. तो 70 years ago, von Neumann told that there is a way we can generate von Neumann middle square method. Middle square method was proposed by von Neumann in a conference in 1949. 1949 की कॉन्फ्रेंस में वॉन न्यूमैन ने बनाया था, ने इसको दुनिया के सामने प्रेजेंट किया. और वॉन न्यूमैन ने ये भी बताया कि दे आर नॉट एक्चुअली रैंडम. इन द सेम कॉन्फ्रेंस ही टोल्ड इन अ कॉन्फ्रेंस, और उसी कॉन्फ्रेंस में उसने ये भी बताया, he told in the same conference, he told that anyone who considers the algorithmic method to be really is in the state of a sin. Not important there. He's in the state of a sin. Okay? वो गुनाहगार है, ये समझते हैं. वो गुनाहगार है. He's in the state of a sin who considers the algorithmic method to be actually or really random. He's in the state of a sin. ठीक है. तो von Neumann का मेथड था क्या? von Neumann का मेथड ये था. उससे कहता कोई भी नंबर ले लें. फॉर एग्जाम्पल start with a seed और बहुत ही आसान था. स्क्वायर इट, pick the middle two digits, the middle. Start with a seed of n digits. Square it. Pick the middle n digits. Pick the middle n digits. Repeat. 1 to 3. Keep on repeating. ऐसे ही होगा ना? Should keep on repeating for the number of times equal to the random numbers you want to generate. For example, if you want to generate 10 random numbers, you will repeat these steps 1, 2, and 3 10 times. So not every time you will start with a seed. In fact, your new number will work as a seed. Repeat 1 to 3. Repeat 1 to 3 by placing the number you obtained in step 3 as the new seed. In fact, we don't call it seed all the time. We call it seed only once, and then we call it a number. So yes, your new seed. So not every time you'll start with a new seed, with the seed. In fact, the next time you run these 1, 2, and 3 steps, you will put, instead of the seed, you will put the numbers you have obtained here in this step number 3. तो अभी हम देखते हैं. So अच्छा, और एक और इंटरेस्टिंग बात यह है कि in part 3 of this lecture, in the next part, I'll show a simulation in Python I prepared for you implementing this von Neumann's method, middle square method. ठीक है? For example, if we have this number, suppose we have this number 675,248, this number, and if you square it, it becomes 45595986150 4. So this number is actually of 1, 2, 3, 4, 5, 6 digits. So we have to pick the 6 middle digits. 2, 3, 4, 5, 6. This one. So we have left 3 digits on the left hand side and three digits on the right hand side, and have picked these 3 digits. 9, 5, 9, 8, 6. 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I pick these 4 digits, and then the next step would be, of course, to square this. Your of random numbers you want to generate. For example, if you want to generate 10 numbers, you will repeat this 10 times. Square, pick the middle, square, pick the middle. You'll keep on repeating that. ठीक है? अच्छा जी, उसके बाद है नेक्स्ट, अब हमारे पास हैं 28 मिनट्स. इन those 28 minutes, और हम ऑफ कोर्स in the next part of today's lecture, I'll show you a Python simulation. I'll show you a Python simulation for this method. And we actually will run that simulation. और मैं आपको आपके हवाले कर दूंगा. And then you will be able to run that simulation for as many times as you want, and you'll enjoy it. The next is we want to explore, or we want to study something about the LCGs, the linear congruential generator, LCGs. Pseudo random number generator. Of course, it also starts with a seed, and it also starts with a seed, and starting with a seed, the next number at n plus 1th step is obtained by multiplying the number at nth step with a constant a, adding another constant c in it, and mod m. Mod m का मतलब क्या है? Mod m मतलब remainder m. We'll start with an m, the modulus, and we'll perform this remainder division. This division doesn't give us a 0. I'll show you how. C is bias, or sometimes we call it increment or bias, and m is modulus. xn plus 1 is the number at n plus 1 level, and xn is the number at nth stage or nth level, and of course at 0th level, the starting level, x0 is the seed that we require to start your simulation or start your random number generation process. So there are 3 families of LCGs. They belong to 3 families. LCGs. There are 3 families of linear congruential generators. The first of them is the original Lehmer RNG, proposed by Lehmer, in which x of n, c is 0, m is prime, and c is 0. We should pick m as a prime number. What the prime numbers क्या होते हैं? They are only divided by their selves or by 1. 1, 3, 5, 7, 9 नहीं होता, 11, 13, 15 नहीं होता, 17. ठीक है? तो ये प्राइम नंबर्स होते हैं, पढ़ेंगे हम, स्कूल में पढ़ते हैं. M is prime and C is 0, and of course the period would be m minus 1, and xn plus 1 is axn mod m. तो C निकल गया इसमें से mod m, क्योंकि C 0 हो गया, जो बाय linear congruential generator proposed by the scientist Lehmer. Lehmer ने ये propose किया था. This is the original LCG. Or the second is m a power of 2. m एक power of 2 है, यानी power of 2 का मतलब क्या है? 2 to the 0, 2 to the 1, 2 to the 2, मतलब 1, 2, 4, 8, 2 to the 3, 8 होगा ना, 2 to the 4, 16, ऐसे होगा. तो m is a power of 2 and m is the power of 2 and c is equal to 0. ऐसे होगा axn mod m, but m is the power of 2. यहाँ क्या है? m prime है. और एक थर्ड जनरेटर है where we don't have any condition except that he isn't 0. एक कंडीशन जो कि सारी LCGs के फैमिलीज पर अप्लाई होती है. The condition is that ax sub n plus c mod m must not be 0. Must not be 0. इसका मतलब क्या हुआ कि they should be relatively prime. axn plus c and m should be relatively prime. This means they, if they are not prime, for example, axn plus c gives you 6 and m is 3, a prime number. So 3 2s are 6 and your remainder is 0. तो ये गलत हो गया. Remainder is 0. So remainder shouldn't be 0 because mod m gives you remainder. ये है mod m, ये mod है. Mod मतलब remainder. You divide this and check mod. You divide this by m and you check your remainder. So remainder is 0. Remainder shouldn't be 0. तो एक बात पर क्योंकि फिर आप उससे आगे चल नहीं सकेंगे. So if remainder is 0, you cannot go any further. Families of LCGs, axn plus c and m, they should be relatively prime to each other. Relatively prime मतलब axn plus c should be relatively prime to m, so that their remainder division doesn't give you a 0 and you keep on going. Otherwise आप आगे नहीं चल सकते. तो उसके बाद तो ठीक है. तो इसमें यहाँ तक यही है. और इसके बाद हम ये देखने वाले हैं, नेक्स्ट हम देखने वाले हैं पाइथन सिमुलेशन. और पाइथन सिमुलेशन में फैमिलीज हम देखेंगे. हम कौन सी फैमिली देखेंगे? हम सिर्फ ये वाली फैमिली देखने वाले हैं. और हमें देखना है कि इसका पीरियड होगा, इसका एक पीरियड होगा m-1 इसका पीरियड है. यानी इसके बाद ही अपने आप को पीरियड आप समझते हैं ना. टी मैंने बताया था कि आफ्टर दैट इट विल स्टार्ट रिपीटिंग इटसेल्फ. तो m-1 इसका पीरियड है. और बीच ओरिजिनल बाय लैमर है. एंड we'll put c is equal to 0, we'll select an m, we'll select an a, we'll put c is equal to 0. और हम इसे करेंगे और हम इसको इम्प्लीमेंट करेंगे. और हम इसको भी कर सकते हैं, बट c isn't equal to 0, कोई भी वैल्यू ऑफ c सिलेक्ट कर लें, हम इसको भी कर सकते हैं. So actually we will first implement in the next section. Next we are going to implement this family of LCGs और फिर हम कोशिश करेंगे हम इसको भी इम्प्लीमेंट करें। तो जब नेक्स्ट पार्ट है उसमें हम 2 पाइथन सिमुलेशंस देखने जा रहे हैं। वन ऑफ देम इज यूजिंग द मिडल स्क्वायर मेथड एंड द अदर इज फॉर दिस द थर्ड फैमिली ऑफ द LCG। ठीक है जी। तो अभी हम ब्रेक करेंगे और विल स्टार्ट एट 10:40। 10:40 पे स्टार्ट करते हैं दोबारा। अभी टाइम हुआ है 10:20 हुए और 10:21 हुए। 10:30 पे स्टार्ट करते हैं। लेट्स स्टार्ट एट 10:30। ठीक है, लेट्स मैं लिख देता हूँ एट 10:30। ठीक है जी, 10:30 पे दोबारा मिलते हैं। थैंक यू।